Problem statement. A radial gate with radius r equal to 3 meters and width 5 meters is installed above a dam spillway as shown in the figure below. For the water level shown, determine A, the horizontal hydrostatic force on the gate, B, the vertical hydrostatic force on the gate, and C, the resultant force, its magnitude, and the angle it makes with the horizontal. So part A of the problem is find the horizontal hydrostatic force. So to do that, we have to find the projection of this curve uh, on the vertical because the horizontal force will be perpendicular. The horizontal force will be perpendicular to the vertical. And then we say the horizontal force is equal to gamma times h bar times area. And of course, the area will be the projected area on the vertical. Gamma will be equal to 9,800 or 9,810, whichever you guys use. H bar will be half of the height. In this case, we can find that by drawing here a vertical. So this is 90 degrees. This is R, which is equal to 3 meters. The angle is 45. So this will be 3 cosine of 45 degrees. And that is equal to 2.12 meters. And this distance here will be equal to R sine of 45 degrees also will be equal to 2.12 meters. Therefore, h bar will be 2.12 divided by 2, and the area will be uh, the vertical, which is 2.12, times the width of the gate or of the radial gate, which is 5 meters. 5 meters. Therefore, the horizontal force will be equal to 1.10 times 10 to the 5 newtons. Part B tells us what is the vertical force acting on the radial gate, the vertical force. So we can see from this plot that the vertical force acting on the gate will be the weight of the water on top of the gate. And we know that the weight is equal to gamma times volume. So we know gamma, but we are missing volume. This volume will be equal to, this volume will be equal to what? Will be equal to the volume of, so what we can do is, okay, this is going to be the volume of this rectangle, right? Plus the volume of this triangle minus this 45 degrees arc. If we do that, then we are going to have the shaded area or the shaded volume. Therefore, what we can say is, okay, and the volume, of course, is going to be the area times the length or times the width. Okay, so then therefore the volume will be equal to 5 times, that's the width, times the area of the rectangle. The area of this rectangle will be 2.12 times, so this will be equal to the radius minus 2.12, and that will be equal to 0.88 meters. Therefore, this is going to be 2.12 times 0.88 plus the triangle, which is a triangle is this times this divided by 2. So it will be 2.12 times 2.12 divided by 2. and minus the arc. The arc is the arc of the 45 degrees. So it's going to be 45 divided by 360. That's the whole thing times pi radius square, and radius is 3 square. Okay. And therefore the vertical um, force will be equal to gamma, and gamma is 9,800 times this volume, and that will give us equal to 2.8 times 10 to the 4 newtons. And finally, part C is the resultant force, the magnitude, and the angle it makes with the horizontal. So let's draw again the curve of the gate. So the gate is something like this. So we have the vertical force acting down, and we have the horizontal force acting to the right, and therefore the resultant will be this, right? This is the resultant force, and this is the vertical force, and this is the horizontal force. The angle it makes with the horizontal we can call alpha, and the tangent of alpha will be equal to the magnitude of the vertical force divided by the magnitude of the horizontal um, force. And then from this, alpha will be arc tangent of vertical force is 2.8 times 10 to the 4, and the horizontal force is equal to 1.10 times 10 to the 5. From this, alpha is equal to 14.45 degrees. And that would be the, the answer of this problem.